All right, 7, 8, and 9, we are solving trigonometric equations involving squared functions. Again, on these ones, we're not staying between 0 and 2 pi. We're doing all of the multiples. Sine, cosine, secant, and cosecant normally have a period of 2 pi and have 2 answers for each one. Tangent and cotangent normally have a period of pi because they have 2 answers, but there are multiples of 180 apart from each other, and so we can combine them into one expression. We'll get to that. You will want to have the sheet handy that we've used for a whole lot of problems where we can look up the tangent, cotangent, and all of those things. So if you don't have that paper out, make sure you get that paper out. Find it in one of your note sheets. And so if I go back here, it says 3 tangent squared of x minus 1 equals 0. We're going to solve it for the tangent. So of course, first of all, we're going to plus our 1. 3 tangent squared of x equals 1. Divide by 3. Tangent squared of x equals 1/3. Then we have to solve that for x, so we end up having to take the square root of both sides. And when we do the square root, we have to have plus or minus our answer. So the tangent of x is going to equal plus or minus. I'm going to rationalize my denominator. So I would have 3/9. So I'd end up with the square root of 3 over the square root of 9, which is 3. So I have the tangent of x equals plus or minus the square root of 3 over 3. So if I grab my paper and I look under my tangent column, I have square root of 3 over 3 being at pi over 6. And then it should be at 180 from that. So if I go down looking under tangent for another positive square root of 3 over 3, that's at 7 pi over 6. Those are 180 degrees apart from each other. One's at 30 and one's at 210. So this can be combined into one answer. Pi over 6 plus k pi, where k is an element of z. So that's going to be one of my solutions. I'm then going to connect it with the word or. Looking for the negative square root of 3 over 3, I have negative square root of 3 over 3 at 5 pi over 6. And then if I keep looking down, it is at 11 pi over 6. Again, those are 180 degrees or pi apart from each other. If I take 1/6 pi plus 1 pi, I would get 7 pi. If I take 5/6 pi plus 1 pi, I get 11 pi over 6. So again, these two can be combined into one answer. And so I'm going to have 5 pi over 6 plus k pi, with k being an element of z being one of the integers. So pi over 6 plus pi gives me 7 pi over 6, and then I go plus pi and get the next one and the next one and the next one. Same thing here. 5 pi over 6 is my first one. If I add pi to it, I get the 11 pi over 6. And then I keep going around and around and around and around my circle a whole bunch of times. So those would be my answers. Number 8, I'm going to move the board up here. So number 8, we're doing cotangent squared. Again, we want to solve it, so we're going to add our 1. 3 cotangent. Cotangent squared of x equals 1. We're going to divide by the 3. So cotangent squared of x equals 1/3. We then have to do the square root of both sides. So cotangent of x is going to equal plus or minus. Again, if I rationalize my denominator, I get the square root of 3 over 3. So this time, same kind of thing. We're just looking for the cotangent of x. So looking under my cotangent column, square root of 3 over 3 is at pi over 3. And then if I keep going down, it is also at 4 pi over 3. Again, if I took 1/3 plus 1, I get 4/3. So that can be combined, pi over 3 plus k pi, where k is an element of z. Or if I do my negative, looking for negative square root of 3 over 3, I'm at 2 pi over 3. And also at 5 pi over 3. Again, if you take 2 pi over 3 plus 1 pi, you end up with 5 pi over 3. And so I'm going to combine that into 2 pi over 3 plus k pi, with k being an element of z. Normally on tangent and cotangent, these two are going to be pi apart, these two are going to be 1 pi apart, and so you'll be able to combine them and only have to put in 2 answers instead of putting in 4 answers. Number 9, this time we have a cosecant. So on cosecant, like sine and cosine, I'm probably going to end up with 4 answers instead of just having 2 because I'm not going to be able to combine them together. Or I might not be able to combine them together. First, we better solve this. So first of all, I'm just going to move my 2 over to the other side. So cosecant squared of x equals 2. I have to do the square root. So cosecant squared, or cosecant of x is going to equal plus or minus the square root of 2. So looking for the positive square root of 2 answer under my cosecant, I'm at pi over 4. Keep going down my list for my positive square root of 2. I'm at 3 pi over 4. If I look at my list under my cosecant for my negative square root of 2, I'm at 5 pi over 4. And if I go down my list again under my cosecant, I'm at 7 pi over 4. Now normally I would have to put all 4 of them together, but if you notice, if I take 1/4 plus 1/2, I'm going to get my 3/4 pi. So what I'm doing is I have a 45-degree angle, and then I have my 135-degree angle, and then I have my 225-degree angle, then I have my 315-degree angle. Well, if I go from 45 to 135, I'm going to add 90 degrees each time. So this would be plus 90, this would be plus 90, this will be plus 90. So I can combine all of that into one answer since each of those are 90 degrees apart. I'm going to start off with my pi over 4 plus, instead of doing k pi, which is 180 degrees, I'm going to do k pi over 2. 180 divided by 2 is 90. So I'm going to take pi over 4, I'm going to add 90 to get 3 pi over 4, I'm going to add 90 to get to 5 pi over 4, I'm going to add 90 to get to 7 pi over 4, and then I'm just going to keep going around my circle. Again, k has to be an element of z. So normally with sine, cosine, secant, and cosecant, I would have all 4 of these answers with the plus 2k pi, but since this one happened to all be 90 degrees apart, they all got combined into one big long answer. Won't happen a lot.